Hello everyone, my name is Pratham Prakash Gurde from CSC Section A, and I am going to present today's topic, which is a voting machine. So the aim of today's presentation is to deliver a working project based on the concept of electronic voting machine. So let us begin with our project. Let's take a project overview. 8085 microprocessor is a basic microprocessor and has a variety of applications in day-to-day life. It requires less support circuitry, allowing simpler and less expensive microcomputer systems to be built. It can be used to build various machines such as automatic traffic light systems, electronic voting machines, etc. So the 8085 processor is a very basic and it can be used for creating simpler machines which do not require some complex circuitry. Means we don't require a high level of uh, what we can say memory generations and processing. There we can use a 8085 microprocessors and it is very cost efficient. So this is my group. We have we as a group have created this project. Are a four-member team, and let us begin with our project. So our project has basically three components. First is the background, then is the setup, and then scope. Let us begin with the background of our project. So what is an electronic voting machine? An electronic voting machine consists of major two components, interface and storage. So what is an interface is that interface is number of candidates appearing for the elections which will be displayed somewhere for the voter to see which candidate to elect, and the storage will be the counter which will count the number of votes the particular candidate has gained or has you can say got elected, how many times he has got elected. So this is our basic setup. We have the candidate list and the memory. We have stored the memory location for storing the memory total number of counts for a particular candidate, such as Rahul's vote will be stored at the memory location 3000, Modi's at 3001, Arvind's at 3002, Mamta's at 3003. And this is try again and thank you will be needed later in the code, but you can understand that this try again is not stored in the letter form. It is stored in numerically with the help of their ASCII values, which are converted to hex. I will explain this later in the code. We have stored one dot Rahul in location 4000 to 4005. Similarly, Modi, Arvind, and Mamta. Let's begin with our code. First instruction is call lecho. What this instruction does is it clears the LCD screen for us to display new for displaying something new. It clears out the old data and gets it ready for new display. Then we get MVI B comma 07H. What this instruction does is it initializes 07 in register B. With what this 07 is, it is the number of letters required for our first candidate, which is Rahul. As you can see, Rahul has 5 letters, then dot, and then 1. So total is of 7 letters. So we initialized B with 07. Then we uh, then Alexa H, 4000 H, what it does is sets the memory pointer to the location 4000, which is the location of Rahul, as you can see. Then we call printf. So what this will do is this will print Rahul at the LCD screen. Okay, and then we do MVI A comma C0. This moves our cursor to the next line. First it print Rahul and then moves to the next cursor for printing Modi, then for printing Mamta, and then printing Arvind. Likewise, uh, then the instruction out 38 will output the in one dot Rahul from output port 38 on the LCD screen. Then we call a delay, and again we store b comma 06 for the second candidate name, which is Modi. So b comma 06 and then again call printf. Similarly, these instructions are also the same and does the same job till are the last candidate's name, which is Mamta. MVIB, 07 call printf. This will print all the names of candidates onto the screen. And our next step is to take input from the user. So these instructions take input from the user. So the first instruction, input slash underscore port EQ00H. This is just helping like a variable. Input port will get the value 00H, and in my program wherever I use input port, the value 00H will be initialized. Then the MVI A 0,00H will clear out all the data from the accumulator and make it free for taking the input from the user. Then we take in an input port. This will take the input from the user and store it into accumulator. Then we need to check whether the input is 1. 1 means it will store for the vote count for Rahul. Okay, so first we initialize the number of votes for Rahul, which is stored at the location 3000 with the help of Alexa h, 3000. Remember, we are storing Rahul's vote count at the location 3000. So this will initialize it to the 3000. Then this instruction CPA 31H. The first, why the 31? Because the ASCII value of 1 is equal to 49, and the 49 is written as 31 in hex. So we always use hex numbers. What the CPI does is it compares the data from accumulator and immediate value, which is 31, and if they both are same, both the values are same, then the zero flag is set. When CPI is immediate value is same as the accumulator value, zero flag is set, and if j j is z means jump if zero. If it is zero, then we need to vote. Means if the value 31 is equal to the value of accumulator, then we need to vote for Rahul. Okay, this vote function I will explain it later in the code. And INXH. What INXH is, if it doesn't set the zero flag, means the value 31 does not match with the value of accumulator. So we need to do INXH, which will take us to the next memory pointer, which is 3001. Now check if input is 2. This will CPI 32 will check the accumulator value. If it is, then vote. If it isn't, then we'll move on to the next candidate. Similarly, 32 will be checked with accumulator's value. If it is, then vote. If it isn't, then move on to the next value. And this is the last one, last candidate. So first it will check with the accumulator value. If it isn't, it's the end of the list. So it may be something invalid the user may have given us as input. So if J and Z, which is jump, if no not 0. If it isn't 0, then we will move on to the invalid function. We need to print something for the user to know if it is an invalid. If it is correct, then we will call vote for Mamta. This is the invalid function, which is called lecho, which will clear the LCD screen. Then we got MVI B, 09. 09 is the number of letters for try again. We have stored it here. As you can see, 9 letters for try again. Then we get LXI H 2160, the location of try again, call printf, and jump to the start. Once we make a vote, whether it is a valid vote or it is invalid, we need to move to the start location where we begin our code. Then this is the vote function. What it does is INRM. INRM, what it does is, remember we initialized the memory pointer to 3000. So INRM will increase the value there at the location 3000. So if it is 24, INRM will do 25. Okay, this is called lecho. It will clear the LCD screen. Then MVIB 09, which is for thank you. This will print thank you after voting. then memory pointer, which is for try again, call printf, and then jump start. So let us move on to the scope of our program. This program can be used for elections used for domestic purposes such as college elections, polls, etc. Means we can use it for variety of elections or small polls. Candidate list can be increased. As you have seen, we haven't stored any values in our registers. We have stored them at memory locations. So we can increase this to a very big extent of candidates. And then we have the number of total votes equals to 256. So this you can say is the limitation of this program, which is the total number of votes equals to 256, because the maximum limit we can store in a memory location is ff, which is 16 into 16, which we get 256. This is the limitation of our code. We cannot exceed the value of 256. Program can be terminated at will. So I would like to thank Dr. Nelson Kuraijam for their guidance with which I was able to present today's topic. We as a group would like to thank you and appreciate your wisdom. And thanks everyone who watched this video till the end. Thank you.